Greetings, Patriots. Please make sure that you get your notebook ready with your guided notes and follow along in the I Do problems. Our objective for today is I will create multiple representations for a proportional and non-proportional relationship. Let's look at the following scenario. John spent $87.50 for 5 tickets to the Spurs game. So we need to figure out, well, how much did he actually pay per ticket? Okay, well, we know if he spent $87.50 for $87.50 for 5 tickets, I'm going to have to figure out how much he's spending per ticket. So I can simply take $87.50 and divide that by 5. And when I do that, that gives me a unit rate of $17.50. So again, you heard me say the word unit rate, right? Because that's my per ticket. So $17.50 is the cost for every 1 ticket. So whenever I have my fraction in lowest terms over 1, that's my unit rate. So if he's paying $17.50 per ticket, well, all I got to do then is multiply $17.50 times 2, and that will give me $35. If I multiply $17.50 on my Desmos calculator times 5, I get $87.50. $17.50 times 7 is going to give me $122.50, and $17.50 times 10 is going to be $175. So I can see that for any number of tickets, I'm always going to multiply by the number of tickets in order to get the cost, which is my dependent variable. Okay, so let's take this specific situation and let's look at it in terms of a graph. So if I look at my x-axis, I know I'm comparing the number of tickets, right, and the cost. So I'm going to go ahead and get a set interval because I'm starting at, well, we can even go back to 0 tickets. If I buy 0 tickets, I spend 0 money, right? So if I look at the following, I'm going to go ahead and go by intervals of, let me try $25, $50, $75, $100, $125, $150, and $175. Okay, let me graph a few ordered pairs on my graph. So I know that if I buy 0 tickets, right, I have $0 I spent. If I buy 2 tickets, that's going to cost me $35 and so forth. So 2 tickets is going to be approximately somewhere here. And then if I buy 5 tickets, $87.50, that's going to be a little closer to $100. And then if I buy 7 tickets, that's going to get closer to $125, which is $122.50. And I know that 10 tickets is going to be exactly $175. So what's nice is that you see your graph taking on this nice linear relationship, guys, okay? Because there's a direct relationship between the cost per ticket. So if we think about how do we calculate your total cost, how do we get Y? How do we get the cost of all the tickets? Well, I take my unit rate, which is $17.50, and I multiply that by the number of tickets that I purchase. And that is my equation for this scenario. So go ahead and talk about this particular situation. I'm just going to transfer the following numbers that I got when I was calculating the total cost per ticket. Okay? And last year, hopefully you should have learned something called constant rate of change. And that's just where I'm taking the change in my Y values and dividing them by the change in my X values. So I'm going to start by just taking the change of these two. So if I do 175 minus 122.50, and I divide that, when I subtract 10 over 7, which I know has a difference of 3, I'm going to get $52.50 divided by 3. And when I do that, I actually get a constant rate of change of $17.50. So now I'm going to do the same thing here. I'm going to take the difference between $122.50 minus $87.50, and I'm going to divide that by 7 minus 5, which I know is a difference of 2. When I subtract and I take the change in y, I actually get 35 divided by 2. So using my Desmos calculator, I see that I get 1750. So what's really interesting, again, is that I'm getting that constant rate of change. Okay, the change that you saw, the 1750 for every one ticket. Okay, so again, take your y values, right? Y minus y over x minus x, and we're going to see if we have a constant rate of change. This lets me know that the shape of my graph is taking on a linear relationship. That's why you see that nice straight line. So the other thing that you should have discussed, hopefully last year, is to check if something is proportional. So how do I do that? My constant of proportionality tells me to take and check every y and x coordinate. So I'm going to take this first ordered pair, 235. Right? 2 tickets cost me $35. So if I take 35 and I divide it by 2, make sure you're doing that in your Desmos calculator, you should get 17.5. If I take 5 and 87.5 and divide 87.5 divided by 5, you should get in your Desmos calculator 17.5. 122.50, I'm just taking my ordered pairs, divided by 7, is going to give you 17.5. And once again, if you were to take every single ratio, you're going to see that you get equal ratios. You get the same constant rate of change here. So this lets me know that I have a proportional situation because I'm observing in this case that my constant rate of change, right, that same rate that I'm paying per ticket, is also equal to my constant of proportionality, which is K. So in situation A, I'm dealing with a proportional situation since both of these values are exactly the same. Let's go ahead and look at situation B. Here I know in situation B that John spent, they've already told me he spent $17.50 for each ticket. All right, great. That's what we spent in situation A. But they also had to purchase a $15 parking pass. Interesting. Okay. Write an equation to determine the total cost of the number of tickets. So, again, 2 tickets I know are going to cost me, right? 2 tickets are going to cost me $17.50 each. But I need to pay for parking, which is a pretty normal situation when you go to the AT&T Center. And I know that's going to cost me $50. I can take my 5 tickets and multiply that by $17.50 and also include my parking pass, and that's going to give me $102.50 and so forth. And if I go on and find 7 tickets, it's going to be the same thing. All right, and that's going to give me $137.50. So if I calculate 10 tickets at $17.50 plus the $15, that gives me $190 that I spent to go to the Spurs game. So in this situation, in order to figure out my cost, right, the cost of the total, I'm going to take my constant rate of change, $17.50 for each ticket, but I need to include the parking, right, that plus 15. So once again, if I look at my x-axis here and my y-axis, and I'm looking at tickets and I'm looking at cost, following the same format that I did, I want to know, and if I were to continue, sorry, let me come back to my table. If I would have 0 tickets according to this process, That means 0 tickets would have cost me $17.50, which is just 0. But just to go and actually get into the AT&T Center, they would have charged me $15 to park. So this relationship's a little bit different, okay? Once again, I'm going to label my y-axis going by the same interval that I went in situation A, and that's 125 and 150, etc. Well, here, what's interesting on my graph is now that 0 tickets, I'm still having to pay to just enter. I'm having to pay a parking fee, right? 2 tickets, though, is going to cost me 50. 5 tickets is going to be 102.5, somewhere around there. Okay, 7 tickets is going to be 137.50, etc. And I can see, though, that my shape of my graph, though, is still going in a linear situation, okay? And again, it's because of that constant rate. I'm still paying that constant rate of change. So, okay, let's go ahead and look at our constant rate of change, because now my cost changes, right, in situation B. Remember, my equation here is 1750 times X plus that $15, right? So here's my constant rate of change of 1750. So I want to see how my constant of proportionality is going to look a little bit different, okay? So I'm transferring my values here. So once again, change in Y over change in X. So go ahead and actually take the change in Y. So I'm going to do on my calculator $190 minus 137.5. That's my change in these two Y coordinates, right? And then 10 take away 7, which I know has a change of 3. So when I take on my calculator and I subtract 190 minus 137.5, that equals $52.50. If I divide that by 3, that gives me $17.50. Let's go ahead and take another set of ordered pairs, right? So if I take $102.50 and I subtract $50, $102.50 minus $50, that's going to give me $52.50. And if I take 5 minus 2, I have to divide that by 3. Once again, I end up with a constant rate of change. So I'm still getting that same rate because that's what I'm paying per ticket. But now we need to see, is this relationship actually proportional? And to check whether my relationship is proportional, I need to take each of my ordered pairs and I need to divide them. So that's what I'm going to do. So let's go ahead and take my y, 50 over my x coordinate, and when I divide 50 divided by 2, I get 25. Let me go ahead and look at my next set of ordered pairs. 5 tickets this time cost $102.50. So 102.50 divided by 5. 102.50 divided by 5 is going to equal $20.50. So right away, I'm going to look and say, wow, my ratios, right, of y over x, my ratios are not equal. So therefore, this is a clue that I do not have a proportional relationship. My ratios have to be equal in order to be proportional. But I do have a constant rate of change. So what do I observe here? That my constant rate of change, and let me go ahead and keep that the same color. My constant rate of change is not the same as my constant of proportionality, or K, as we call it. Okay, they're not the same, they're different. However, because I have a constant rate of change, I still know that I'm going to get a nice linear relationship, except it's going to look and start at a different place on my graph. All right, let's go ahead and continue. So let's compare situation A and situation B is what we need to finally do. Okay, and so if I look at situation A, I had the equation y equals 17.50x per ticket. In situation B, I had $17.50 for every ticket, but I had to pay $15, right, for my parking. So I can see that my equations look somewhat the same. They have the same constant rate of change, right? That's 1750. However, when we check their ordered pairs, right, this one, all ratios are equal. I'm dealing with a proportional situation. This is proportional because every single X and Y coordinate gave me 1750. However, when I checked the ratios here, right, your ratios are not equal. This is an indicator that you're dealing with a non-proportional situation. And it has to do with that service charge there for the parking, okay? So I just showed you an example of something that's proportional and something that's not. And the other thing I want to make note is your constant rate of change and your constant of proportionality were the same value of 1750. So now you'll have an opportunity to look at another situation where you will have to review it, graph it, write the equation, put it on a table, and then go check the constant rate of change and the constant of proportionality and ask yourself, what do you observe? Do you think this is proportional or not proportional? Have a great day, Patriots. See you tomorrow at Zoom so we can discuss what you're observing.